I'm really thankful to Todd for the invitation to present. I'm a little bit different, I think, but I think that's really good than a lot of people probably in the audience. I'm a user experience designer and a consultant, so I don't have a full-time job. Everything is part-time, and an author and instructor occasionally. So, and what I do is talk to a lot of data scientists and take the wonderful work they do and try and translate that to output that users who may be completely different, or not data scientists, but analysts of different kinds, that they have a whole different worldview. And somehow all the wonderful work that's done by the data scientists has to be translated to the view of these analysts or who are the decision makers. Because at the end of the day, there's a long process, but at some point, there's going to be data at one end, and there's going to be a human making a decision at the other end. It may be a very long, circuitous route, but that's going to happen, at least at some point. So this talk is about, it's basically a combination of two things. One, a talk I gave on cybersecurity visualizations recently. And I kind of munged that down into a very short format. It's very compressed, highly compressed. And also, the project that I'm going to talk about is really going to be at the end. And it's, I'm excited about it. Unfortunately, it's going to be happening mostly this coming weekend. I got my whole genome sequenced, and I'm going to a conference in Dallas where I'm going to look at my genome, all the genomic data, the whole, not the 23andMe thing, but like the whole thing, more or less. It's a longer story there, but a lot of data, and kind of analyze it. So it's very fraught for me, and I'll show you some examples, but I will know more next week. So if anyone wants to follow up with me about it, please feel free to, and I'll know a lot more about myself than I do already. I'm not really a quantified self guy, but I wanted to sort of eat my own cooking here and see what it was like. I do a lot of work in health and medical. So anyway, the main concept I want to start off with is this idea of signal to noise in visualizations. And basically, how do you listen to data and get output that's meaningful signals and not noise? So signals can mean different things to different people. From my worldview, signals are potentially meaningful things in the data, patterns in the data that you can pull from and actually make decisions, get insights, and draw important conclusions, meaningful conclusions. Whereas noise is irrelevant, meaningless patterns in data. There's tons of patterns in data, but what actually matters in the data? Sometimes this noise could actually lead to misjudgments, mistakes, problems. So, that's what I consider my worldview, kind of the noise in the data. And the signal and noise can be helped or hindered each, at various stages of the process of data. So reducing, I think Todd shortened my talk to reducing presentation noise. So doing that, it doesn't begin or end with a visual design or the presentation layer. It's really a full stack kind of thing. Starting with the data lifecycle, every place in that cycle, from the planning and preparation to the collection, the summarization, the statistical analysis, presentation, and so forth, the building implementation side, all of that can introduce noise or help increase the signal. And then the other thing, which I'm extremely interested in, is the noise or signal that is happening between that person's ears, the interpretation of the data. So it's not the data that's presented is not necessarily what's understood by this person, this physician in this case, because there's other interference in her own head, possibly, that could be conflicting with what she's seeing. So how can visualizations and presentations help to counter that? So as I said, this was kind of munged down from condensed down from a much longer talk. There were originally 5 concepts or considerations, but I've now made them 4, and probably skip over a couple of those or go quickly over a couple of those. But I'm going to take it to a very kind of simplistic level for these concepts, but I hope to maybe to prompt your thinking about the output of this data, what people are going to do with this data, and how they may experience it. So I'm going to talk about context and emphasis, perception and distortion, feedback and tuning, and then you go garbage in, garbage out. And so I'll touch on all these things very briefly. So people are really, really excited about all the data they can now pull up, and they're showing it everywhere and showing everything, and it's wonderful. But I mean, of course, when the humans are involved in the decision-making process, more is not necessarily better. And I don't know if anyone here has heard of the alarm problem. Imagine you're in an ICU and you have you're a nurse there, and you hear a bunch of different things going off at the same time. You become immune to it. So the significance of any particular alarm becomes lessened often. And there are so many distractions that the things you need to pay attention to, you don't. And this is certainly a problem in cybersecurity and other areas as well, medicine. So I like to start with the basic analogy to sort of reframe this problem, the alarm problem. And it's pretty much as basic as it gets, a smoke detector. We just sort of take it for granted, how it works and what it does. I mean, it's very important. We need it when we need it. But it's not arbitrary. So a smoke detector, generally, if it's working right and it does as expected, some designer said, OK, if there is a certain amount of smoke in the room, it's going to trigger this thing, which is going to set off a very loud, piercing noise that's going to alert the people to that, right? And maybe have a red color or something that's going to sort of prompt people to action, right? Oh, that makes sense. That's what I would call a signal. It's got input. The data is the smoke coming in, and the output is this really piercing signal. But this design is not inevitable. The designer could have chosen to say, well, I'm going to make this thing that's going to just let me know with a pleasant chirp every 15 minutes that it's working fine, there's no smoke in the air, everything is good. So from my perspective, and I think from probably a lot of people's perspective, that would be considered noise. That is it's technically true. It's information, and it's sort of helpful in a way, but it's really annoying information. So, this may seem like an obvious thing, but when you look at a lot of data dashboards, which I'll show in a minute, this sort of concept is often repeated. There's also this idea of sort of sensitivity and specificity and severity, level of severity. So imagine if your smoke detector, was super sensitive and had like these fine gradations, and you had multiple sensors that are picking up like really bad smoke and then sort of bad smoke and then like a light, maybe someone's perfume or something else. There's something in the air that's not normal or typical, but you're not really sure what to do about it. There's also this issue of like crosstalk. So let's say I have two smoke detectors. One's saying everything is working out fine and it's all good. Another one is saying there's a problem. The two kind of tend to cancel each other out. You end up with kind of this noise where it's hard to really figure out what's going on. And so this analogy, I think, is true for like data science and basically for a lot of data visualization and data apps in general. For cybersecurity and for medicine, there's a lot of warnings, there's a lot of information that's being pumped out, there's a lot of detectors detecting all kinds of things, and then being displayed to users, but it really becomes sort of lost. So, like let's say this is Homer's, one of his displays. I mean, this is not that far from a lot of dashboards that I've seen, honestly. There's some meaningful information in there, but there's also a lot of noise, I would say, visual noise. You're not really looking at what's necessary. So from a design perspective, just because you have data, just because it's true, doesn't mean you should show it, at least not really in the same level as the really critical stuff. So for example, there are redlining things in there, so maybe they should be given better prominence. So even obvious ideas like prioritization, disclosure of information, based on real actionable facets of it and severity level, should be kind of represented visually. So you give higher priority to, say, the reactor 1 core temperature if it's overheating. It's got a higher visual prominence. Maybe things like workplace accidents are kind of important. You show them, but they're given a little bit less priority. And then everything else, all the other gauges are just are there, they're just, all you have to say is they're fine. Everything is good. You don't have to show the green on your dashboard for everything. And this may seem obvious, but again, I think a lot of dashboards that I see do that prior screen, what that prior screen does. And a lot of executives that I talk to say, why are you showing me stuff that is working? I want to see the problems. I want to see what's going on I want to know, sure, that things are OK if they're OK, but I don't need to have that really in my face. So I think that's one way to sort of reduce the amount of noise, is really think thoughtfully about what you're presenting and the data that's being bubbled up. OK. I'm going to talk about another kind of what I call noise, and that's the sort of perceptual noise, or the way that people will look at a visualization. It doesn't really work that well here, but and maybe interpret things in a way that is not intended. So I don't know if everyone sees the bar there on the right. Does it look like it's got this bar here? Excuse me, on the left. Does everyone see that in the middle bar there is a gradation? You can all see that? It doesn't exist, of course. It's exactly the same bar as the right. But the point is that your brain is basically making some corrections internally and saying the background is a gradation, and so it's making the foreground, basically, that middle smaller rectangle, have a gradation. The point of this is, like, you know this now, I know this, I can look at this, I can see the actual solid bar there, and I cannot think my way out of this. I cannot not see that gradation in that middle bar. So your perception and the part of your brain that doesn't think is quite powerful. So that means that there are visualizations or sort of representations of data which will, by their essence, basically distort the data to a certain extent. In this particular case, I mean, time is short. Does anyone know why this is a problem? This kind of representation is a problem. Basically, it's showing in the red areas of that pink area the level of mortality in the British Army and during the Crimean War due to battle. And the sort of the gray area is due to neglect, bad hygiene, and those kinds of things, sort of unnecessary casualties and deaths. And the cycle is over the course of a year. That's a prior year. Does anyone have a guess about why why this is a little bit problematic? So basically, by choosing to do this really cool design, this is actually Florence Nightingale, who's sort of a famous nurse who's known more for her nursing work than her visualization work, but she was actually a bit of a pioneer. This area here is really kind of a false artifact. It's an artifact of the way this is designed. It should be a straight line, basically. That by making this into this sort of pie kind of thing, you're having this huge area here to kind of over-represent the amount of fatalities. So in this case, it worked for her favor because she was trying to make a point. But basically, when I see this, I see all of this area, right? Which I should only really see this comparison as a line. Does that make sense? So, you know, as in the prior, more simple example, when we see something, we see data presented a certain way, we can't help necessarily what our brains are doing with some of that information and the interpretations that come from it. Another sort of source of noise is, again, the preloaded kind of cognitive biases. So when, you know, data is never pure when it gets into the human head. Basically, it's being interpreted, it's being filtered by your experience, your knowledge, your expectations, understanding, and emotions. So in this particular case, a patient is being told that she has a positive mammogram. And the doctor doesn't really know what that means. And the patient definitely doesn't know what that means. But the doctor thinks there's an 80% chance the person has cancer. Well, it turns out that that's not at all true. I mean, this is the data that she's thinking about. And the problem is that she's sort of thinking about this in a certain way. She's thinking about kind of maybe unconsciously that the patient has breast cancer. She already kind of has that because it's a positive mammogram, so that's triggered. And she sees this first column only, that out of positive mammograms, 8 out of the total have breast cancer, but 2 don't. But what she's neglecting to think about is that there's this whole other set of people who have a positive mammogram and who don't have breast cancer. So it's that sensitivity and specificity I was talking about earlier. Like a mammogram is very good at detecting a certain level of information or data, you know, but it's not. It's very sensitive, but it's not specific. It doesn't tell you whether that thing that it's seeing is cancer or something else. And often it's the case that it's something else. So how do you combat that sort of cognitive bias, or can you reframe this? So this is a very simplistic drawing, but again, I'm trying to sort of break it down to essential elements and say, well, maybe we can just think about this problem not in a spreadsheet or tabular form, but like in a sort of a tree-like structure. And put into terms that maybe the patient and the doctor both can sort of understand and recognize. Out of 1,000 screened women, 103 tested positive. Out of those, 8 had cancer and 95 did not. So it's closer to 8% chance that she has cancer rather than 80%. So visualizations can help kind of reduce that sort of interference, that noise, it's very easy to happen, when you're in a kind of a highly charged situation. If you're a physician, maybe you're afraid to show you don't know something. Bayesian statistics may be a piece of cake for everyone in this room, but statistics in general are not that simple for people to process. That's not a natural thing for a lot of people. Okay. So a couple other things, and I'll get to the genomic thing also very quickly. And that is the idea of reducing noise by this sort of feedback mechanisms or tuning mechanisms. So I just have one example here. It's a application called Haystack, and they're looking for some problematic relationships in a hospital setting with some hospital data. And the point of this slide, why I'm showing it, is that it's got a place where you can, say yes or no to this. Like, is this the machine has basically spit out this relationship and says maybe this is important, but it's allowing. So it's producing this thing, maybe signal, maybe noise, letting the human to make that determination and then send that back. So then next time the machine comes up with new things, it's going to be a little bit more tuned. It's going to be a little bit sharper. So it's a sort of very simple user interface element, but it's very powerful because it's enabling this very rapid, powerful collaboration between, say, machine learning and the human intelligence aspect of it. So they can quickly go through and eliminate what's irrelevant. So maybe a couple more minutes? OK. I will. OK. Visualizations, I think probably all of us experienced like the problems with bad data. And they're quite significant. And part of the problem from my perspective as a user experience designer, user interface designer, is that the data entry mechanisms are bad. That if it's too much trouble, people are just going to throw in whatever the hell they can just to finish the job. Or it's not clear, and they're going to put in, there's some sort of weird coding convention. So they're going to say, in this particular case, there was the age of the patient was undetermined. So they said, OK, it's this code, which ended up turning into 999-year-old patients. OK, so that's great for the hospital because their survival curves were actually quite good with these nearly 1,000-year-old patients. A mentor of mine, Ben Schneiderman, actually took a look at this data. He visualized some of the hospital records data and immediately saw these outliers of nearly 1,000-year-old patients, and was able to sort of reduce that noise, that bad data in the system. And so it's a super, I think on both ends of the sort of user interface design world, being able to make the data entry clear, clean, crisp, and easy so that the data gets in right, and then making sure that the data is actually good. Both those things, make sure it's clean and ready for effective use, because if you visualize the wrong data, it's all worthless. Even if you have the most beautiful data models, everything you've done to that point, if the data isn't good, it may or may not work out. OK, so as I said, this weekend I'll have a lot more knowledge. Sunday, so far so good. But I got my whole genome sequenced. by a company called Illumina, and they have guinea pigs basically who are getting their whole genome sequence, and they have an application. They're going to let us basically give us our genome data, and then let us kick the tires in this thing and look for all kinds of fun things like health risks, which is all about health risks. And that's part of the interface. It's another part of the interface. I'm not going to go into it because haven't really dived in, and it's also super dark. But other than to say, when I was talking about signals before and about the smoke detectors and murmurs, there's a lot of potentially very scary things in here. I want to know what's important and what isn't. And they're making attempts in what I've seen so far to show things like, this is not me, but showing what kinds of conditions I might be susceptible to, again, not me, and what kind of drugs are good I can respond to or I would not respond to, which is really important information. The problem is a lot of this is still very hard to tell. A smoke detector is sort of giving this sort of ambiguous signal. What do I need to pay attention to when I've maybe got hundreds of these things to look at and consider? So I think that's probably leave it there. There's one other example, but I think I'm going to skip through. This is something actually I did work on, looking at genomic expression, basically. This is more for researchers, and it's about workflow. But I don't think I'm going to dive into that too much. So anyway, thank you. And I don't know if you have any questions or OK.